Hi, hello. This is Mathematics in Modern World. Let's talk about problem solving and reasoning. So we have the following subtopics. We have inductive and deductive reasoning, in which is your assignment last meeting. We are going to talk about the intuition, proof, and certainty. What are their differences? Then we're going to discuss the Polya's four steps in problem solving. Also, we're going to discuss the problem solving strategies. Then we're going to talk about the mathematical problems involving patterns. And last, some recreational problems in mathematics. Okay, first let's have inductive and deductive reasoning. Inductive reasoning is simply as when you're drawing a general conclusion from a repeated observation or limited sets of observations of a very specific examples. Okay, we have examples below. This is actually the conclusion drawn by using inductive reasoning, which is called conjecture. For example, number one, let's have a very specific statement that is 1 is an odd number, 11 also is an odd number, and 21 is an odd number. So the conclusion is therefore all number ending with 1 are odd numbers. So that is an example of inductive reasoning. Another example we have essay test is difficult. Another statement, problem solving test is difficult. Therefore, all tests are difficult. So that is from a very specific test, essay, and problem solving to a general conclusions that all tests are difficult. Next is deductive. Deductive is just simply as we're going to draw a general to specific example, okay, or simply from general case to specific, wherein inductive from specific to general, okay, conclusion. Okay, for example, here we have deductive example, all birds, okay, we generalize that all birds here, okay, have feathers. Ducks, an example of a bird, okay, which is ducks are bird. Therefore, okay, conclusion, ducks have feathers. Another example, all iguana, generalize all that iguana or lizards. Snake is a reptile. Therefore, snake or lizard. Okay? Now, actually, it doesn't mean that whether your argument or statement is correct. Though you just have to have a supporting uh, arguments to testify or conclude in your to your conclusion. Okay, that will verify it. So that is done. Simply as when you say inductive again, deductive is from specific to general, while deductive is from general to specific. Next, let's talk about intuition, proof, and certainty. When you say intuition, okay, it is a reliable mathematical belief without being formalized and proven directly and serves as essential parts of mathematics. Actually, okay, this word's intuition carries a heavy load of mystery and ambiguity, and it's also somewhat dangerous. Yes, of course, just like say, for example, okay, mostly girls have this kind of intuition, and it's which what they believe on. Okay, whatever they believe, okay, that is their intuition. It doesn't mean they're really correct or wrong. Okay, because it is their perception or intuition. Okay, that's their feeling. Okay, wherein if proof, okay, it is an inferential argument of mathematical statements such as theorem, wherein or theorems is really proven. Okay, theorems is different from theory. Theory is not yet proven. Okay, it is just a theory, but when it becomes a theorem, that is already becomes a proven theory. That is what we call it a theorems. Okay, when you say certainty also, okay, when certainty, okay, this is a mathematical knowledge which is correctly formulated, okay, which is you really think that is 100% that, okay, you are correct. Okay, it is forever beyond error or and correction. Okay, that is really you sure. Okay, not just 100%, but more than 100%. But you are correct. Okay, that is kind of, as you remember, the mathematical characteristic of the mathematical language. We have precise. Okay, it has to be precise, concise, simple, and powerful. Okay. Then we're going to talk about Polya's four steps and problem solving. This was made by George Polya, okay, mathematician. Okay, he has four steps in problem solving. And these are, first we have to understand the problem or understanding the problem. Second is you're going to devise a plan. Third is, okay, the third step is to carry out the plan. And last is to look back. Okay, actually carry out plan. That means you're going to work on it. Okay, work with your solution. And look back is like you're going to verify or you're checking. Okay, understand the problem. That means you're going to, okay, understand the questions. Okay, what is being asked. Okay, devise a plan. That is you're going to identify the formulas that you need to do or the things that you need to consider. Okay, to furthermore explain this, okay, let's talk about how to understand the problem. Okay, first step is understanding the problem. What are we going to consider? Okay, what is the goal? What is being asked? The condition. What sort of a problem is it? What is known and unknown? Okay, that is, okay, what should be the given and what is the unknown problem? Is there enough information? So you have to also think of that. Can you draw a figure or illustrate the problem? Of course, this involving a drawing, graphical, or illustration, okay, of your problem. Then if there is a way to restate the problem in your own words, that you're going to translate it in your own understanding. How are you going to translate it? You can understand, and that means something much easier. Okay, try to find a way to restate the problem. Okay, in your own understanding or in your own words. Okay, second is to devise a plan. Devise a plan is you're going to act it out. Okay, that means you're going to work it out. Okay, be systematic. Systematic. That means you have to plan your way. How are you going to solve the problem? Okay, then you're going to work backwards. Work backwards. If not, then you're going to go back again to read the problem. Okay, that is part of the devise a plan. Then you're going to okay, consider special cases. Okay, such as mga just like mga regular problems. Okay, special problems such as different problems which is can be easily, okay, remembered. Okay, those are special cases. And another is to eliminate possibilities. And we're going to perform an experiment. Draw a picture or diagram. Then make a list or table or chart. Okay, that is we're going to, okay, somewhere like you're going to draw your picture or diagram or make a table or chart. Okay, as will describe your problem. Okay, use variables such as x, y, and so on and so forth. Okay, any variables you want to use. Oh, hold on, let's go back. Okay, as I said, okay, you're going to look for a formula. Then you're going to write an equation or model. Look for a patterns, okay, or a pattern or patterns. Also, you're going to use direct or indirect reasoning. Okay, we've discussed that a while ago. Then we're going to solve a simple version of a problem. So as much as possible, you're going to make it simple. Okay, not like a very complicated one. Okay, then we're going to guess and check your answer. Okay, trial and error, checking here. Okay, to carry out a plan, okay, you're going to, okay, from your formula, from your illustrations, drawing, graphing, something like that, okay, you're going to be patient on it while working, okay, while acting on it. Okay, then while working, okay, from your device plan, you're going to work carefully as well as patiently, carefully. Then we're going to modify the plan, or let's have try a new plan. Then we're going to keep trying until something that will works, okay? Or if you have some idea, oh, maybe this is something closely enough, okay, that maybe this will be the good to use. Then we're going to implement this strategy, okay, or strategies, okay, in step one, which is devise a plan, okay. When you say carry out the plan, that means this is your support to your devise a plan, okay, by implementing it. Then you're going to try another strategy if it won't work, okay. Then we're going to keep complete, again, accurate records of your work. Okay, though you have a mistake, then still you have to record your wrong solutions. Okay, then go on so that you may not will forget it. Then be determined. Okay, and don't get discouraged. Okay, you have to be determined. Okay, if the plan that doesn't work, there more just likely. Okay, same understanding for what will be in this carrying or carry out the plan. To look back is that to look for an easier solution. Okay, modify it, simplify it. Okay, if does the answer make sense? But then in look back, actually, we're just simply simplifying into checking or verification. Okay, of your solution. Okay, from your working it out, then or act it out. Okay, this is by checking the results of the original problem and considering the formulas you made or your solutions generated. Then you are going to interpret the solution. Okay, that would be based on the facts of the problem. Then again, okay, after you check, then you have to recheck it again. Okay, recheck the computations. Okay, that involves the solution. Okay, later on, we're gonna have an example of how we're going to strategize this problem solve. Okay, also you can, if can the solution extended more general case. Okay, if there is a general case of the solution, then you're going to ensure that all of these conditions are related. Okay, if the problems are met, then determine whether there is another method of finding the solution. Okay, then you have to determine that. Okay, if there is really another method. Then last, I think, okay, you're going to ensure the consistency of the solution that will be, you're going to express it or presented it as simpler as it is. Okay, let's have an example. Okay, the length of the top of the rectangular is 15 inches more than its width. Okay, the width is the smaller, it is a little bit smaller the length than your length of the area of the square. That is wherein your square has an area of 1,350 square inches. Then we're going to find the dimension of the table. The dimension of the table based from your given area. Okay. Okay, the area is equals to length times width. Okay, but let's do the step one first. Okay, of Polya's 4 steps in problem solving. So to understand the problem, of course, we have to know the given. Okay, this is my length and this is my width. So we are looking actually for the length and width. Then the rectangular table, okay, that indicates, okay, it has 15 inches longer than the width. Okay, that means your length is equals to, okay, plus 15 of your width. Okay. So next is we're going to go to our step 2. So devise a plan. So in devise a plan, okay, we're going to make a formula or formulas. Okay, actually this is already a formula, but a sort of a given, but we can use this also as your translation. Okay, for your formulas, we're going to distribute this. Okay, your equation given. Okay, form from your device. Okay, We're going to devise a plan. This is our formula. Then we're going to substitute the area. The area is 1,350 square meter as square inches. Then we're going to multiply your length times width, but of course we're going to replace our length by width plus 15. Okay, so that is now then, okay, your length is W plus 15 times W. Okay, that is your W plus 15 is your length. Okay, so you may now be able to multiply this W times W and 15 times W. Okay, or your width. So let's carry on the plan after we already created our formula. Okay, then let's carry out the plan. So let's use the formula. Okay, so perform this, multiply. Okay, use the operation. It will now be then W squared because you're going to multiply W times W and W times 15. That is 15W. So if you're going to reform this, okay, into a quadratic, because this is, you have the second degree of your exponent and 1 here, and you have your, um, you have your, you have your, what do you call this? You have your whole number, okay? Then this can be solved using quadratic equation using your calculator or by factoring, in which is the factor for this is simply as, okay, W plus 45, okay, multiplied by minus 30, okay, if you're going to factor this out, okay. That is actually W squared plus 15W, okay, minus 1,050 is equals to 0, okay. So 0 is here, okay. Then this is our factor, okay, of your quadratic equation. So then if we're going to find the root of this W, okay, you have your W negative 45. Oh, sorry for this. This is 45. This is not 40. Okay, another is we have, okay, if you're going to transpose that, okay, your root of your W will be 30. Then, of course, we need to choose the positive. Okay, again, this is wrong. This is not 40. This is 45 supposedly. Okay, because if you're going to multiply 45 times 30, that is 1,350. So we have to choose the positive value. So we're going to substitute also the value of your length, since we already have the value of your width. Since our length is 15 longer than your width, so that means this is the given, okay, based from our problem. So we're going to substitute 30, okay, this will be 45. Your length now here is 45. This is not 40, okay. Next and last, okay, we are going to look back then. How to look back? Okay, perform. Okay, we're going to use the equation, okay, we made, okay, by checking it. If the answer is correct, okay, we may use this or this one, okay, actually, it can be equation or equations. So this is 1,350. Okay, your length is 45, your width is 30. That is actually, okay, 1,350 is equals to 1,350. Or we may be able to use this. Length is equals to width plus 15. So we're going to substitute the value of your length, that is 45. Then your width here is 30 plus 15, that is 45. Okay, 30 plus 15, that is still 45. Okay, next, let's talk about problem solving involving patterns. Okay, but before that, okay, patterns is really, when you say pattern, okay, in mathematical patterns, okay, it is really all about prediction, of course. When there is a pattern, we can predict, okay, what will be the next sequence of the pattern. Now, for sequence, there are two classification that we may be able to describe or classify. We have infinite sequence and finite sequence. When you say finite, okay, that is countable. Okay, it is where the domain of the function consists of first and positive integers only. That means integers that can be countable. Say, for example, this is, okay, the difference is increasing to only one. Okay, 1, 2, 3, 4, 5, 6, 7, up to 7 only. or increasing counting number by 2, 2, 4, 6, 8, but in uh, even, and we also have increasing by 2 in odd, okay, starting from 1, 1, 3, 4, 5, 6, 1, 3, 5, 7, 9, okay, up to 9 only. But when we say infinitely, it will be a continuing term, okay? It will be continue infinite until any term of that you want to find or solve, okay? That is the infinite. It depends on how you're going to, what is the given of the problem, okay? Then also, let's say for example, okay, of your infinite sequence, we have 3, 6, 9, 12, okay, and so on and so forth, okay, to the n term. And as well as this sequence, we have 1, 1, 2, 3, 5. Okay, this sequence is counting, increased by counting 3, right? And this one, okay, what do you think is this? Actually, this is sounds familiar. This looks like a Fibonacci sequence, okay? You are adding the first two number, okay, and the result and succeeding, such as 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and 3 plus 5 equals 8. Okay, that is a Fibonacci sequence, and so on and so forth. Okay, and here, okay, we have 1, 4, 9, 15, 25, 36. Okay, that will be classified later on what sequence number or sequence difference that it will be. The pattern is submerged or the same difference. Okay, so let us have first the general sequence, wherein a general sequence actually is just identifying, okay, the nth term. Let's say the first term is A1, the second term is A2, the third term is A3, and so on and so forth, okay, until to the nth term, okay. That is the general sequence. That means there should be in A1, A2, A3, A4, A5, A6, and so on and so forth, okay. That should be the general sequence, okay. It cannot be the general sequence cannot be like skip counting by kung ano sad, like you're saying A1, A3, or unarranged, okay. It should be increasing, like you starting from A1, that is your first term, your second term is A2, A3, the nth term, okay, and so on and so forth, okay. That should be the general sequence. Okay, then let's have an example of the sequence, the difference of a sequence, in which we're going to find the difference of a sequence. Okay, to predict the next term of the sequence, we're going to find the next term of the sequence, also this one, okay? For A, okay, to predict the difference of a sequence, we have to know, okay, the same difference of every sequence of a number, okay? Until when, okay? It could be in the first, second, or third, or even it will be in the fourth, okay, in which they will be equal in difference, okay. Say for example, okay, in order to furthermore learn to know this, okay, let's have example A. Let's just copy this problem, okay. You have your sequence 3, 7, 11, 15, 19. Then we have to make it a little bit space, okay. Then we're going to find the difference, okay, between numbers, okay. It's the difference of 7 and 3, 11 and 7, 15 and 11, 19 and 15. That is actually, we find it in the first difference that they are both the same, 2 equal to 4, right? Then also, if we're going to find the next term, okay, after your 19, okay, number, that is the term is that first, second, third, fourth, fifth. Okay, the sixth term of this sequence, that is now then, okay, we know that the difference is 4. Then we will just be simply adding 4 to 19. So 19 plus 4, that is equals to 23. So the answer here is 23. The next sequence of your 19 number, or the sixth term, is 23. Okay? Because that is the next term. Okay, the next term naman of the B is we have 6, 9, 14, 26, 50, and 91. That is 1, 2, 3, 4, 5, 6. Okay, the seventh term of the sequence of this problem or given. Okay, so let's copy the given. Okay, let's have a little space, okay, in between two numbers so that we will be able to find the difference of the numbers. Okay, this will be our first difference. Okay, we will do something like this. Okay, this will be our differential table. So the difference of 9 and 6 is 3, 14 and 5 is 5, 14 and 9 is 5. Okay, 26, 14 is 12, and so on and so forth. Okay, that is 41, 24. Our second differences, it will be the same now. So the difference of these numbers are, we have 2, 7, 12, and 17 if you're going to subtract. So still wala gyapon. But then, okay, in your second, we may be able to identify that on the next difference, it will be the same. Such as when you subtract 7 by 2, that is 5, 12 by 7, that is 5, and 17 minus 12, that is 5. So on the third, they are now the same. Okay, this is our first differences, second difference, and third difference. Okay, now if we're going to find the next term or the seventh term of this sequence, okay, we have to start from the bottom. So we know that this is 5 here. So 5 plus 17, that is 22. Now again, we're going to add 41 and 22. So that is now then 63. And your 63 added with your 91, that is 154. Now your seventh term or your nth term that we were looking for, such as the next term is 154. Okay, are we clear? But if, let's say for example, you're going to find the ninth term, so you have to find first the eighth term and then the ninth term and so on and so forth. Okay, you just expand. Okay, the differences. Okay, and I guess that's okay. We'll just talk a little bit on recreational problems because mostly in recreational problems, okay, this actually involves puzzles, okay, mathematical puzzles of numbers and sort of a games, okay. In ancient times, especially in Chinese, okay, they use this as their games or recreational, kalingawan lang, okay. So let's say, for example, one of the ancient mathematical recreation in China, okay, is the magic square. The magic square actually, okay, it could be, okay, this one is 3 by 3, okay, magic square order of 3. Okay, as you can see here, okay, there are no numbers, okay, that has, okay, the same. There are numbers from 1 to 3, 4, 5, 6, 7, 8, 9, okay, 9 numbers. Okay. Now every summation here called by column and rows, okay, they are equal to 15. 4 plus 9 plus 2, that is 15. Okay, and so on and so forth. Okay, also to your column, that is equals to 15. And as well as to our diagonal, that is still 15. And as well as here, okay, it's still 15. 8 plus 5 plus 2, that is still 15. Okay. Also, if there is 3, there will be also square of 4. Pagyapoy 5 and so on and so forth. Okay. Now, for magic square of 4, that is equals to 34. Okay. Just like in your 3 by 3. Okay, rows and columns. Okay, we also have another recreational palindrome. A palindrome actually is a number. Okay, it can be a words or phrases in which is the sequence or characters or symbols. Okay, that will be read. Okay, will be always the same if you read it backward. Okay, backward and forward. Okay, say for example, if you're going to read 131. Okay, if you're going to read okay backward like here again, okay, in your last, that is still 131, right? Same as 12321 or 12321. Okay, if you're going to read forward and backward, they are just read as the same. So we have lots of palindrome square actually. Okay, this is the link if you can see. Okay, below this one. Okay, this is the link. Okay, we have http. Okay, www.finguan.com. Okay, /palindrome. Okay, that HTML. Okay, we're going to click this. Thank you.